Okay, more higher maths fun. This is question 9. So, what have we got? Some cos stuff and some sine stuff all together in an expression, and I want to combine it more neatly and tidily into a single expression. So apparently this equals the same thing as this, which is pretty cool. Okay, when is that possible? What k and a are going to make this be the same as this? Well, same advice for every single trig question, guys. Find a place to use a formula and use it. So here is a place I can use a formula. K cos 4x plus a. That is the same thing. Using the formula sheet to expand out cos of a plus b, I get k lots of cos 4x cos a minus sine 4x sine a. Great. Okay. You can expand that out for giggles if you like. K cos 4x times cos a minus k sine 4x times sine a. Okay. Now what's going to happen? Apparently all along this was supposed to be equal the same as this. So this is supposed to be equal the same thing as cos 4x minus root 3 sine 4x. So let's play spot the difference, one of my favourite games. Okay, cos 4x appears there and there. Here I just have one cos 4x. Here I have k times cos a times cos 4x. So basically at the end of the day, k cos a has to equal 1. This times this times this has to just give me this. Okay, similarly, here is sine 4x, here is sine 4x, minus k sine a has to be the same thing as minus root 3. In other words, k, let's just write it properly, minus k sine of a has to give me the minus root 3. Why? Minus root 3, lots of sine 4x, minus k times sine a times sine 4x. They've got to be the same. They've got to be equal. They've got to match. Okay, so let's work with this. Let's call this equation 1. Let's call this equation 2. Here's a sneaky trick bit for these questions. Always the same sneaky trick. I'm going to square them and add them. I'm going to do 1 squared plus 2 squared. So square 1 and I get k squared cos squared a equals 1 squared, which is 1. Square 2, let's just simplify this, forget them, times by minus 1 both sides, whatever you want to call it. Okay, so square this, so I've got k squared sine squared a equals, what is root 3 squared is going to be 3. So square them both, and now I'm going to add them. What do I get? This, add this, so k squared sine squared a, that was this one, plus k squared cos squared a, okay, that was this one, equals this, add this, okay, 1 add 3, which is, I believe, 4. Now, simplify this side, I can put k squared on the outside, and I've got sine squared a plus cos squared a. Which is kind of cool, right? Because sine squared a plus cos squared a, okay, that's one of the formula that we've known since Nat 5. Sine squared plus cos squared equals 1. So all I've got is that k squared times by 1 equals 4. K squared equals 4. So k equals plus or minus 2, the square root of 4. Now it did tell me back in the question that k is supposed to be positive. So what I can do is something like k greater than 0, so let's use therefore, that's more fun. Therefore, k equals 2. Great. Now, same way I solve any simultaneous equation, what am I going to do? I'm going to put k equals 2 into my equations. It's very important here that you put it into both of these equations in this type of question. So let's try putting it into 1. What have I got? I should have 2 cos a equals 1, which gives me that cos a equals a half, And again, this is one of the special angles. We found this one out earlier. So A is got to be 60. Why? Because cos of 60 is a half. Number 2, here it was. K sine A equals root 3. So K equals 2 apparently. So 2 sine A equals root 3. That means that sine A is root 3 over 2. And I'm like, oh, love it. I love a good root 3 over 2. When does that happen? Actually, that happens when A equals 60. Since they're both the same, we are laughing. A must be 60. Oh, actually, we're not laughing. Check it out, right? They wanted the radians thing. They want it between 0 and 2 pi. So it's not 60 at all. What is it supposed to be? Well, 180 is pi. So 60 is 1/3 of the way to 180. So actually, A is going to be pi over 3. There you go. A is pi over 3. K is 2. And that's what the question asked me to do. Great.